Hello guys, I'm Hash, currently doing my master's in data science from the UK. And in this video, I'm gonna pull up one of my old hackathon projects which I've submitted to Lab AI. This project has been completed in a 7-day time frame using generative AI models from Google Cloud, specifically Gemini text models and Gemini embedding models. Let's dive into the video. This is a project demonstration submitted to a challenge hosted by Lab AI. The project name is SHAi, Sustainable Hydroponics AI. Meet our team. We are a group of 2 people, Pranav and myself, Harish. We are both AI developers. Let me give you a little introduction about what is hydroponics, because SHAi is built on top of hydroponics data. It is a domain-specific LLM specifically built for hydroponics and to promote sustainability. Hydroponics is a soil-less agricultural method. Instead of growing plants in soil, we will be using nutrient-rich water solution. This has a wide advantage over traditional farming and also aligns with sustainability. Problem and solution. So the problem statement is that there is a lack of comprehensive and reliable guide coupled with the relevance of biased information online poses a significant barrier to widespread adoption. This is a wide knowledge gap. Whenever a new person, maybe you are a frustrated guy who wants to do hydroponics farming, but you go on the internet and you're just going to see lots of information. Some information may be true or some information may not be true. Internet is always biased, right? The solution we propose is a domain-specific large language model assistant tailored specifically for hydroponics farming. This AI is going to give comprehensive information on various aspects such as hydroponics methodology, sustainable ways, best practices, common misconception, disease management, etc. Product. SHAi is built in a Streamlit application over the framework LlamaIndex, and the vector database is Zilliz. We have used Google's Palm as a LLM model and also as an embedding model. So we'll be seeing the entire architecture in the next slide. We also used TrueEra to actually evaluate our model in various aspects because we don't want this LLM to hallucinate. That's why the TrueEra comes into picture. It is really a very good tool whenever we want to make a production level LLM. Market and trend. Hydroponics is being fastly adapted all around the world. When I was doing my college project in hydroponics, a small farm setup, there was not many people who are doing hydroponics. But now there is a major adaptation in North America and Europe. Market trend. This is a time series prediction from 2017 to 2022. The time series has been predicted to 2027. It has been expected to grow exponentially. And also, due to its increased demand, you see there is always demand for the food, but there is always demand for a good food, organic food. So that's what this trend prediction is showing us. Let's go to the methodology. This is the app structure. Firstly, let's talk about the data ingestion. We have stored our data in a markdown file, which is located in GitHub. And then we are using Palm embedding to embed the documents inside of the Zilliz vector database. Let's move to the application. So users who are going to interact with this application, right? So it is a chat application. Basically, they will ask a question and the application will give an answer to them. So whenever a user query the application, it has been pushed to Palm embedding, and then the Palm embedding is sending all of the query embeddings to the vector database, Zilliz. And then Zilliz will try to push some of the context and relevant chunks to the LLM, which is going to be Palm text bison used from the Vertex AI. And this LLM will try to answer according to the context and the relevant chunks which is provided by the vector database. And then it will just produce a response. Finally, this whole LLM is being wrapped with the TrueLens. It's been really helpful for us to evaluate the model. This is how we have used TrueLens. Our model really got a high relevance score, and also the groundedness is really good. The QS relevance, it is actually 0.7. Why? Because I've asked some questions which is not in the vector database, and the model tried to answer. So that part we have to improve. And also on the right side, we can able to see the records of user input and response, and we can see the relevance, QS relevance, groundness, and we can also see the latency, how lately the model is being responding to us. This is our application, SHAi, Sustainable Hydroponic AI. I'm imagining myself to be a guy who wants to set up a hydroponic farm in my terrace. So I'm going to ask, how do I set up a hydroponic farm in my terrace? Yeah. The model is going to take this input and it will think. All of the app structure which I've shown you, it's all happening in the back end. Yeah, we got the response from the materials, and it is actually telling us the entire process. It's amazing, right? And I also linked the Streamlit applications code in the description. Also check that out. This is the app hosted and the URL. It is also available in the description, so please check it out. So yeah, that's it guys. Thank you. If you like the video, subscribe and like so that I could post more contents like this. Thank you.